Quadratics exam preparation. By now you should have covered the following topics within this section. We started out with an overview of quadratic functions and their graphs. We introduced the base quadratic function y equals x squared, and we introduced the general form of the quadratic equation y equals ax squared plus bx plus c. We then moved on to transforming graphs of quadratics. We discussed the various transformations that we can apply, for example, vertical translations, horizontal translations, and vertical stretches. We then discussed quadratics, the turning points, and completed square form, how we can represent the general form of a quadratic equation, ax squared plus bx plus c, and convert it into completed square form, k times x plus p squared plus q. And by converting it to completed square form, we can simply read off the turning point as negative pq. We then moved on to solving quadratic equations graphically, where we just read the roots from the graph. And then we moved on to a number of topics where we discussed how we can solve quadratic equations algebraically, initially by factorizing, and then by using the quadratic formula, and then partially solving quadratic equations, determining the nature of the roots by calculating the discriminant b squared minus 4ac. And then we discussed problem solving using quadratic equations, where we can take real world problems, represent them as quadratic equations, and solve them. This topic will now cover the types of question you're likely to see in your exam. Now, quadratics is a big section, and you'll likely have multiple quadratics questions to answer in your exam, totaling up to 9 or even 10% of your total mark. For example, in 2019, there were 3 questions representing approximately 9% of the marks in the exam. And in 2018, there were 4 questions representing up to 10% of the exam's marks. And questions can be asked on a wide variety of topics. You can be asked questions on solving quadratic equations graphically, by factorizing using the quadratic formula, or by calculating the discriminant. You can be asked to determine a quadratic equation from its graph. You're presented a graph and you have to form a quadratic equation, normally in completed square form, by reading the graph. And then there are questions on problem solving using quadratic equations, and those questions are normally worth a lot of marks as well. And then we can also be asked to sketch the graph of a quadratic equation, and to do that, we determine where the graph cuts the x-axis, where it cuts the y-axis, and the turning point. Okay, so please ensure you study this section thoroughly and practice as much as possible. There is a lot covered within quadratics, big section, lots of different skills and techniques, and as we can see, there are a lot of marks on offer in the exam, so it's really important we study this section as thoroughly as possible. Our first question is from 2018, paper 1, question 5, and it's for 2 marks. On the left hand side of the screen, we can see that we're asked to solve x squared minus 11x plus 24 equal to 0. Now, if we're asked to solve a quadratic equation to a number of decimal places or significant figures, then we use the quadratic formula. Those questions are usually in paper 2. But if we are not asked to solve to a number of decimal places or significant figures, then it's likely that all we need to do is factorize to solve the quadratic equation, and those questions will usually be in paper 1. This question's in paper 1. It's not asking us to solve to a number of decimal places or a number of significant figures, so we can solve by factorizing this quadratic equation. So let's do that. We factorize x squared minus 11x plus 24 by finding 2 numbers that multiply together to give you 24 or add together to give you negative 11. And that's x minus 3 times x minus 8, and that's equal to 0. So either x minus 3 equals 0 or x minus 8 equals 0. And using the balance method, that tells us either x equals 3 or x equals 8. So we have solved our quadratic equation by factorizing. And as covered in our previous topics, we should check our answer. Let's take x equal to 3. Plug it back into our equation, and we get 3 squared minus 11 times 3 plus 24, which is 9 minus 33 plus 24, which is equal to 0. And we can do the same for x equal to 8. We can plug it back into our equation and check our answer. So this question just required us to solve algebraically by factorizing, so that's what we did. Now our next example 2019 paper 2 question 6 on the right hand side asks us to solve the equation 3x squared plus 9x minus 2 equal to 0 and give your answer correct to one decimal place. So the fact that it's asking us to give our answer correct to one decimal place tells us that we need to use the quadratic formula. This is a paper 2 calculator question and we need to use the quadratic formula. The quadratic formula is given to us in the exam formula sheet. X equals minus b plus or minus the square root of b squared minus 4ac. What we need to do is compare our equation to the standard form, ax squared plus bx plus c, and read off the values for a, b, and c. So a is 3, b is 9, and c is negative 2. We then substitute those values into our quadratic formula, and then we simplify, and we get x is equal to negative 9 plus or minus the square root of 105 over 6. So that gives us x is equal to negative 9 plus square root of 105 over 6, or x is equal to negative 9 minus the square root of 105 over 6. And giving our answer to one decimal place, this gives us x is equal to 0.2 or x is equal to negative 3.2. Now, both these questions asked us to solve a quadratic equation which is set to 0. But one question, we had to solve it algebraically by factorising. Well, actually, we could have solved the first one using the quadratic formula as well, but we don't need to do that. If you're not asked to solve to a number of decimal places, it implies that the quadratic equation can be factorised, so we can solve it by factorising. In the second question, we are told to give our answer to one decimal place, so we should use the quadratic formula to solve questions such as those. Our next two examples are on the nature of the roots of a quadratic equation. An example on the left hand side, 2018 paper 1 question 8 for 2 marks. Determine the nature of the roots of the function f of x equals 2x squared plus 4x plus 5. When we see this phrase, nature of the roots, it tells us that we need to use the discriminant b squared minus 4ac. We calculate the discriminant b squared minus 4ac. If it's less than 0, then the quadratic function has no real roots. If it's equal to 0, the quadratic function has one real root. And if it's greater than 0, the quadratic function will have two distinct real roots. Okay, so in order to calculate b squared minus 4ac, we need to compare our equation to the general form, ax squared plus bx plus c. Then we can read off a, which is equal to 2, b is equal to 4, and c is equal to 5. Now we can work out the discriminant, b squared minus 4ac, and that's equal to 4 squared minus 4 times 2 times 5, which is 16 minus 40, which is negative 24. Now, as negative 24 is less than 0, as our discriminant, b squared minus 4ac is less than 0, this function has no real roots. We're asked to determine the nature of the roots, so our answer is this function has no real roots, and we show all our working to get the full 2 marks. Okay, in our next question, which is from a specimen paper, paper 2, question 12, find the range of values of p such that the equation px squared minus 2x plus 3 is equal to 0, where p is not equal to 0, has no real roots. No real roots tells us that we want to use the discriminant. And if we want to show that a equation has no real roots, we want to show that the discriminant will be less than 0. Okay, so let's compare our equation to the general form, ax squared plus bx plus c. We can see that a is p, b is negative 2, and c is equal to 3. So we want to show that we want to find the values of p such that b squared minus 4ac, our discriminant, is less than 0, because b squared minus 4ac has to be less than 0 for a quadratic function or a quadratic equation to have no real roots. So let's substitute in our values of a, b, and c. This gives us negative 2 squared, negative 4 times p times 3, which gives us 4 minus 12p is less than 0. Now let's use the balance method to get p on its own. So this subtract 4 from both sides gives us negative 12p is less than negative 4. And now we want to divide by negative 12. Now recall, the inequality switches when we multiply or divide by a negative. So this gives us p is greater than 4 over 12, or simplified down, p is greater than a third. So the range of values of p such that the equation has no real roots is p has to be greater than a third. So in this example, we had to use the discriminant rule b squared minus 4ac is less than 0 for no real roots to solve for p, while in the previous example we needed to work out the value of the discriminant, determine whether it was less than 0, equal to 0, or greater than 0 to determine the nature of the roots. So when you see the word roots within a question, nature of roots, no real roots, has one real root, think to yourself, I will need to use the discriminant b squared minus 4ac to answer this question. Our next example is from 2019, paper 1, question 9, and is for 3 marks. The graph shows a parabola. The maximum turning point has coordinates 420 as shown in the diagram. Write down the equation of the axis of symmetry of the graph. Then the equation of the parabola is of the form y equals b minus x plus a all squared. State the values of a and b. Now the fact that we are given an equation in the form y equals b minus x plus a all squared, this tells us that we'll be using completed square form to answer parts of this question. Okay, let's write down the equation of the axis of symmetry of the graph. Now you should know that a parabola is symmetrical, and it's symmetrical about the line that passes through the turning point, the axis of symmetry. So the axis of symmetry is through the turning point. So x equals 4 is the equation of the axis of symmetry of this graph. Okay, for part B, we want to express the equation of the parabola as y equal to b minus x plus a all squared. Now we should know that completed square form for a quadratic is k times x plus p all squared plus q, where the turning point is minus pq, and k is equal to -1 if the graph has a maximum turning point, which is the case for this example. K is equal to 1 if the graph has a minimum turning point, but k is equal to -1 if the graph has a maximum turning point. Now reading the graph, the turning point is 420. We can see that from the graph. This tells us p is -4 and q is 20 because the turning point is negative pq. And as stated, k is equal to -1 because we have a maximum turning point. Now let's substitute those values into our completed square form, k times x plus p all squared plus q. This gives us k, -1, so it's negative x minus 4 all squared plus 20. Let's rearrange that, and that gives us 20 minus x minus 4 all squared. Now we have our equation in the form requested by the question. So we compare to the form in the question, and we can see that a would be -4 and b would be equal to 20. So for part 1 of the question, it's fairly straightforward. Axis of symmetry, you just read it off the graph. Axis of symmetry passes through the turning point. For part 2, we needed to represent the parabola as an equation in completed square form. To do that, we used the turning point and we used the nature of the turning point. It's a maximum turning point, and we then put it into completed square form. We rearranged it, and by rearranging it into the same form as the form asked for in the question, we were simply able to read off the values for A and the values for B. Our next example is from a past paper. It's from 2018, paper 1, question 16, and is for 3 marks. Sketch the graph of y equals, in brackets, x minus 6 times x plus 4. On your sketch, show clearly the points of intersection with the x-axis, the y-axis, and the coordinates of the turning point. Okay, let's draw on our graph. First thing we want to do is find where the graph cuts the x-axis, and we know it cuts the x-axis when y is equal to 0. So setting y equal to 0 gives us 0 equals x minus 6 times x plus 4. And we know, using the balance method, our roots are then x equals 6 and x equals -4. So let's draw those 2 points on our graph, -4 and 6. These are the points where our parabola will cut the x-axis. Okay, the graph cuts the y-axis when x equals 0. So let's substitute x equal to 0 into our equation. Y equals 0 minus 6 times 0 plus 4. which gives us negative 6 times 4, which gives us negative 24. So the point 0, negative 24, is where this graph will cut the y-axis. So let's draw that point on our diagram as well. Now we want to find the coordinates of the turning point. Now we can find the coordinates of the turning point by taking the equation from the general form and converting it into completed square form. However, we already have the roots of this equation. We know a parabola is symmetrical, so the turning point and the axis of symmetry will be halfway between the two roots. It will be halfway between negative 4 and 6. Now the distance between negative 4 and 6 is 10. Half the distance between these 2 points is 5. So the axis of symmetry will actually be x equal to 1. So let's draw that on our diagram. Now you can see that visually, but if you wanted to do that mathematically, then we're showing that in the bottom left hand corner of the screen. It'd be 6 minus 4 over 2, which is the distance 10 divided by 2, so half the distance would be 5. And then if we want to find the point, well, the second point is 6. You'd have to take 5 off that, which would take you to 1. So the axis of symmetry would be 1. So in this scenario, you can see it's fairly easy. Negative 4 and 6, half the distance between the two, well, is 10 divided by 2 is 5. So half the distance, the axis of symmetry is x equals 1. Okay, so the x coordinate for the turning point is x equals 1. What's the y value when x equals 1? Well, let's substitute that into our equation. Y equals 1 minus 6 times 1 plus 4, which is negative 5 times 5, which is negative 25. So our turning point will be 1, negative 25. So let's draw that on our diagram. Now the last thing we need to do is join these points together to draw our parabola. Now we can see that we're going to have a minimum turning point here just by the nature of the points that we have. However, the other thing to keep in mind is that if you have a positive x squared, you will have a minimum turning point. If you have a negative x squared, you will have a maximum turning point. So let's draw on our parabola. And as we can see, we have a minimum turning point. So in this example, it's slightly different. We are asked to draw or sketch the graph of a quadratic function. And in order to do that, we were asked to find the roots of the function, where the graph cuts the x-axis. We were asked to find where it cuts the y-axis. And we were asked to find the turning point. So you step through one at a time, find the roots, find the y-axis, find the turning points, plot those all on, and then join the points with a line to show your parabola, to show your graph. Our next question is from 2016, paper 1, question 10, and it's for 3 marks. Sketch the graph of y equal to x minus 3 all squared plus 1. On your sketch, show clearly the coordinates of the turning point and the point of intersection with the y-axis. Okay, so this is a completed square form question. Completed square form, recall, is k times x plus p all squared plus q. And the equation of the graph that's been given to us is in completed square form. Okay, the turning point when an equation is given to us in completed square form is negative pq. So we can read the turning point simply off the equation when the equation is in completed square form. Now, one point of note, k is equal to 1 for our equation, which tells us the graph has a minimum turning point. If k were equal to negative 1, the graph would have had a maximum turning point, but as there's no negative sign before the brackets, x minus 3 all squared, then k is equal to 1, and our graph has a minimum turning point. Okay, so p in our equation, y equals x minus 3 all squared plus 1, p is equal to negative 3, and q is equal to 1, which tells us our minimum turning point is negative pq, so it's negative 3, which is 3, and q 1. So our minimum turning point is 3, 1. It's negative pq. Okay, let's draw that on our graph. And the axis of symmetry, again, I've not asked for this, but just as a reminder for you, the axis of symmetry will pass through the turning point. A parabola is symmetrical, and it's symmetrical about the axis of symmetry, which passes through the turning point. Okay, we're also asked to show where the graph intersects with the y-axis. Well, it cuts the y-axis when x equals 0. So let's put x equal to 0 into our equation, y equals 0 minus 3 all squared plus 1, which is minus 3 squared plus 1, which is 9 plus 1, which is 10. So the point where the graph cuts the y-axis is the point 0, 10. So let's mark that on as well. Now we can draw our parabola. We know that it has a minimum turning point, so we can draw our parabola on. And as we can see, this parabola does not touch or cut the x-axis, and this parabola would have no real roots. The question isn't asking us for that, but it's just a kind of observation for you to take note of. Okay, so we were asked to show the coordinates of the turning point and the point of intersection on this graph, and to sketch the graph, and we did that. We read off the turning point. Because the equation was given to us in completed square form, we simply read off the turning point from the equation, and then we worked out the y-intercept by setting x equal to 0, and then we drew the points on the graph, the turning point, the y-intercept, and we drew our parabola. Our final example is from 2016, paper 1, question 12, and is for a big 7 marks. The diagrams below show a rectangle and a triangle. All measurements are in centimeters. We can see the rectangle's dimensions are 2x plus 1 and x plus 8. And the triangle's dimensions are, it has a perpendicular height, shown in yellow as 3x, and its base is 2 times x plus 5. Now, in part A, we're asked to find an expression for the area of the rectangle. In part B, given that the area of the rectangle is equal to the area of the triangle, show that x squared minus 2x minus 8 equals 0. In part C, it says, hence find algebraically the length and breadth of the rectangle. Okay, now, given that part B has a quadratic equation within it, this should get your mind into the mode of thinking that this is a quadratics problem solving question, and you're going to use the skills learned in the quadratic section of your course to solve this question. Okay, first thing we'd normally do with a question like this is, if we didn't have a diagram, we'd draw a diagram, we'd mark on all the dimensions we'd been given, but we already have a diagram, so we can jump straight into the solution. Let's find an expression for the area of the rectangle. Well, the area of the rectangle is equal to the length times the breadth, so that's 2x plus 1 in brackets times x plus 8 in brackets. Again, another quadratic expression is formed from the area of the rectangle. Okay, in part B, given that the area of the rectangle is equal to the area of the triangle, show that x squared minus 2x minus 8 equals 0. So in part A, we developed an expression for the area of the rectangle. What we don't have is an expression for the area of the triangle. So let's develop one. Area of a triangle is equal to half the base times the height, which would be half of 2 brackets x plus 5 times 3x. A half times 2 is just 1. So this simplifies to x plus 5 times 3x, and multiplying out the brackets, we get 3x squared plus 15x. Now we've got an expression for the area of the triangle, similar to what we developed in part A, an expression for the area of the rectangle. Part B tells us the area of the rectangle is equal to the area of the triangle. So this tells us 2x plus 1 times x plus 8 is equal to 3x squared plus 15x. Now we want to rearrange these expressions to try and get the expression given in B, x squared minus 2x minus 8 equal to 0. So we want to get 0 on one side of our equation. So let's first multiply out our brackets on the left hand side. This gives us 2x squared plus 17x plus 8 equal to 3x squared plus 15x. Now let's use the balance method and try and get 0 on one side. So let's subtract 2x squared from both sides. This gives us 17x plus 8 equal to x squared plus 15x. Now let's subtract 17x. That gives us 8 equal to x squared minus 2x. And finally, let's subtract 8 to get 0 on one side. And that gives us 0 equals x squared minus 2x minus 8, which is what we've been asked to show. So by developing an expression for the area of the triangle and setting the area of the rectangle equal to the area of the triangle and rearranging, we were able to earn the marks for part B. Okay, on to part C. Part C says, hence find algebraically the length and breadth of the rectangle. Now the word hence tells us what you did in part B, use that to work out part C. So we're really being asked to solve this quadratic equation, find the values of x which satisfy this quadratic equation. Now, as we've not been asked to find the length and breadth or x to a number of decimal places or significant figures, we don't need to use the quadratic formula. We should be able to solve this quadratic equation by factorising it. So ask yourself, what two numbers multiply together to give you -8 and add together to give you -2? Well, that's -4 and 2. So our factors here are x minus 4 and x plus 2. That then tells us that either x minus 4 is equal to 0 or x plus 2 is equal to 0. So x is equal to 4 or x is equal to -2. Now a width, a length, a dimension can't be negative. So x is equal to 4 is our solution. Now that we have our solution, we can work out the length and breadth of the rectangle. The length is 2x plus 1, so that's 2 times 4 plus 1, so the length is 9 centimeters. And the breadth is x plus 8, so that's 4 plus 8, which is equal to 12 centimeters. So for part C, we had to solve the quadratic equation algebraically. We solved it by factorising to work out what x was. Once we knew what x was, we then worked out the length and breadth. Okay, now one key point to make here, actually a couple of key points to make. The first point is this. If you didn't manage to show part B, x squared minus 2x minus 8 equals 0, if you didn't manage to develop that quadratic equation, it doesn't mean you can't do part C. You can still go on and do part C because you're given x squared minus 2x minus 8 in part B. So don't think, I can't do B, I won't do C. You can pick up marks for C even if you couldn't do part B. The other note is, look at the wording of the question. If a question says hence find algebraically, the word hence tells you, well, what you've just done in parts A and B, you're going to use those to do part C. And then the last point of note here is problem solving quadratic questions do appear in the exams frequently and they're worth a lot of marks. This was 7 marks. You'll have other ones worth 4 marks and 6 marks. So they're worth a lot of marks. So it's important that you recognize them. Recognize problem solving questions involving quadratic equations and develop the skills and the techniques and strategies to answer such questions, as they are worth a lot of marks in the exam. Next steps, section practice and section tests. So by now you should have covered all the learned material for this section. Your next step is to practice. Practice for this topic covers all the skills learned within this section. You'll be presented with exam level questions, and as with other practices, you'll be supported with hints and full work solutions to assist you where required. Please practice until the system confirms you have mastered the section skills. Once you've mastered the practice, please take the section test. Here again, you'll be presented with exam level questions but without the support of hints and worked solutions. So this test will be similar to your end of section school test and the exam itself. And in this way, it'll help gauge your level of understanding of the section as a whole. Once you've completed the section test, you should review your test results. The system will mark your test and provide worked solutions for all the questions taken. You should study the solutions in detail for any questions you happen to get wrong, and then close out any related knowledge gaps by revisiting the relevant learn and practice areas as required. Repeat this cycle as many times as required until you consistently achieve a score of 90% or greater in the section test. Remember, the work you put in now will develop your skills and also build your confidence, both of which will greatly assist you at exam time. One final note, print off the crib sheet which summarises all the key skills learned within this section. You can add your own additional notes to the back of the crib sheet, and in that way you will have all your summary knowledge in one place, a handy one-page reference for this whole section.